Welcome to Physics in the AM. This is the vectors coming at you. And we have had technical difficulties, but we were just going to take this up and different answers from different people. So, 32, attention problem. I won't read through it. We've done it. We're read through already. Page 106, 32. I'm going to do my diagram, my free body diagram. 42 kilogram mass. The force of gravity in this case is equal to 42 kilograms times negative 9.8 meters per second squared. I'm going to use negative 412. That's 411.6 round. The tension force can't exceed what was it, 450 newtons, otherwise it lasts. So we're going to use 450 newtons and knowing that it can't be. In the y-axis, and that's all we're worried about, I'll label it, the sum of the forces, mass times the acceleration. And we're asked, pretty sure we're asked about the acceleration. What's the greatest acceleration the workers can give the bucket as they pull it to the roof? Okay. So we've got sum of the forces. The Ft with the direction included, the tension, plus the Fg, which will be negative, mass times acceleration. I'll sub in there. We're going to use 450. And it's already at negative 412. The mass was 42 kilograms. We're trying to find the acceleration. So that's just arithmetic. Is that what we had set up? 38 newtons? Okay. People are getting 10. What was different? Yep. Sure. Yep. That is from the mass of 42 kilograms for the weight force and negative downward direction. The acceleration due to gravity. I rounded it as 411.6. Just for safety. There was a 42.0. No, I should have actually just called it 410. So. Anyone else? So I'm curious where people like Kendall, were you a person who got 10? What was different there? This step here? Okay, but she came up with 411, right? Oh. Oh, okay, so that's where, okay, got it. Okay. Does this make sense now? And then it comes out to decimal 9. I got decimal 9. That's in the positive direction in that y-axis. Okay. So you rip it up any faster than that, or any more acceleration than that, it'll bust the string. Is the whole idea. Anything else on this one? The second one was a relatively quick question. Diego and Micah are trying to fix a tire on Diego's car. Having trouble getting the tire loose when they pull together. Micah with a force of 23 newtons, Diego with a force of 31. They just barely get the tire to budge. Now that's a pretty weak pull, right? 23 newtons. Just the other day I had Mackenzie pull with your little finger, 20 some newtons, right? You're not going to budge much. Like this is not a, it's just for math reasons. What's the magnitude of the strength of the force between the tire and the wheel? This is not equal and opposite idea though. You've got two forces pulling, 31 newtons and 23, I think. Okay. And that's, I'm going to call it the force of the tire. It's the force of friction, you can call it too. I'm not going to just change it. I don't care what you call it, small m. This is the friction of the tire being on there and stuff like this. T for tire, FF for the friction. I don't care. But they aren't asking anything about the mass or anything like that. It's what's the magnitude of the strength of the force between the tire and the wheel. So that's right, it is a friction. And in the x-axis, always label your axis, sum of the forces. And sum of the forces is, pardon me, plus the 31 newtons pulled by the one person and 23 newtons pulled by the other. Now let's read this carefully. We just barely get the tire to budge. This is just on the verge of going from zero, no movement, to move. I'm going to call it mass times acceleration. Zero. For the acceleration. That makes my math pretty simple. What's friction in this case? Tire and wheel. 54. 54 newtons. Okay. It depends. I use negative 54 because that's the way I drew my diagram. You can draw it from mirror image and it would be positive. It's all relative, right? Okay. Okay, we're going to take a look a bit friction for the next half hour. Now, jot this down. We've already mentioned friction before, but I use a small f. Big F force of friction is equal to this mu symbol. It's the Greek letter mu. Looks like a U with a tail at the front as well. Fn, where n is the normal force. U is the coefficient of friction. Push 25 kilogram wooden box across a wooden floor at a constant speed of 1 meter per second. How much force do you exert on the box? Okay. I'm going to get you guys to jot that down and we'll continue. Okay, I'm going to start this up. Now, I don't have a lot of information here, but it's enough to solve this problem. It involves friction. So, a wooden box, I'm going to draw a box, and that's what I usually do with my free body guy. So, I'm going to draw it on a wooden floor. Here's my box. So, I'm going to try to move it across the floor. Sure. Because the actual charges within, like, the hydrogen volumes that we have those. But I've never had success demonstrating it. I use cooking oil and definitely demonstrate that it's available. Should not. And the heat system that you know. No. was this? 45. Is anybody in the later part of the alphabet that needs to pitch big? I'm sure you could hit. They'll be calling in the next few minutes, you know. So just go with it. So what was it? 25 kilograms. Oh, I was recording the whole time. It doesn't matter. Anyway. So we know as a given that there's a normal force pushing up. On the floor. Now I'm going to move that. I tend to figure it there. But it's really the floor pushing up. And it's equal and opposite to the gravitational force, the weight. Now, we know how to calculate the weight force. Maybe I'll just do this as an aside. Just messy. FG. Yeah, 25 kilograms times negative 9.0 meters per second. 25 times negative 245. I'm going to label that here. And I'm going to label this as positive. It's not falling. Or anything like that. Now, if I'm pushing or pulling, and it doesn't matter, I can basically I think of a push as from behind the box, right? But I can actually put the arrow on this side. And I'm not drawing this to scale. We're wondering, I'm going to call this a P, pull, push force. No. This is in the friction section. It doesn't explicitly say this, but you know from common sense. If you're pulling something, there's going to be friction between the surface, right? So the friction force is always against the motion. And it should be equal and opposite if it's at a constant speed. That's what we do. Let's work out the x-axis. Because that's what we want. How much force do you exert on the box? So in the x-axis, insert the sum of the forces, mass times acceleration. Now, as soon as you see constant speed, that's at the x-axis, I can just say, well, this is 0. I don't care what the mass is. We know what the mass, but it doesn't matter. It's 0. Mass times acceleration. The force of friction and the force, push force. Add up to that. They're equal and opposite that time. Arithmetic-wise, it's probably good enough.
Any grade call to the last name H2Z, who made music, you go get them done. And anybody else who has been in today's class for their receipts can also go down to the library. Thank you.
Okay, so mathematically, we know this. We also know that the force of friction, though, we have a formula for this. I'm going to sub it in. How much I can do for you? It's awful. Not to dentist, not to me. Okay, anyways, back to this. So I've subbed that in. Oh, the formula, mu FM. Okay. And I don't think I wrote something down. I think it's on. Just so you know. I don't think I didn't write something down. Okay, if I look up something on here, and you would have to have this. The mu values for certain substances, you can look them up in a table. Question? Yes? Okay, mu is a Greek letter, and it's kind of like the equivalent of the letter M, because that's where it falls in the alphabet, the Greek alphabet, but it looks more like the letter U with a front tail. It's kind of like a handwritten M, though, it's squished together a little more. You follow me? Like that. No, that's fair. Okay, we would have to look up the mu value for this wood on wood. And for kinetic friction, movement friction, it is 0.2. That's a value that has to be given, or else you have to figure out in the problem. Okay? So that I've looked at. So I'm going to put this in here. FP equal to negative 0.2. Fn, which we already have, is 245. And the pull force in this case is decimal 2 times 245 is 49. The only reason why I have it as negative, oh, just a second. You know what? It's a double negative. I'm just thinking this through. Depends how you drew your diagram. I'll show you what I mean. This sign thing, and I just look at my diagram afterwards. And I know that my pull is to the right, so it should be a right hand. It should be a positive force. Let's see where I screwed up. Minus the force of friction. The force of friction on my diagram is to the left, correct? So I have to just build in the negative sign, and I'm going to just build it in right now. I'm not too caught up on these negative signs. That's where that should come in. I'm just going to put it in. And so it actually would be on. And it's only because I drew my diagram. I could have drawn the mirror image diagram and it would be the opposite side. The mu itself is just from a list. You could Google it up or a textbook. The textbook has it. Have it on rubber and concrete, wood on wood, wet concrete, steel on steel, dry, steel on steel with oil. Like, it just has different combinations. Okay, so that's why I put that in blue. Now, I want you to try some problems. Page 120. And you'll see a list. I'm going to try 17 through 20. Okay, and that's going to be it, because you got 15 minutes to try these problems.